morning, everyone. I love being at data center events where the technology is problematic. Hopefully we will overcome some issues in time. I'm going to talk about dispelling myths and accelerating a circular economy for the data center industry, and I think I've had a pretty good sort of intro from various people who have spoken in front of or before me. So I am the academic lead for the CEDaCI project, which is an acronym for the circular economy for the data center industry. And before we start looking at the nitty-gritty, let's just think for a minute or two about what the industry has achieved, certainly since the introduction of computing, as we know it in the Second World War, and then the World Wide Web at the late 1980s and beginning of 1990s. How many people have actually become connected, which is quite staggering, nearly or over 64% of the global population now. And there are at least around about 7 million data centers in the world. There's concentration in Northwest Europe, which is where our CEDaCI research project is based. And so far, the emphasis has been on really uninterrupted operation and energy efficiency within the sector, which obviously is really, really important. And we expect growth to continue. And again, it's quite staggering, you know, thinking already we've got 7 million data centers around the world, but on a sort of 2018 baseline, by 2050, provision will have increased 500% globally, which is quite astonishing as more and more people and objects, etc., become connected. Now, that speed and scale of development is absolutely unprecedented in human history. And everybody has been sort of running to keep operation going. And so the whole sector has really evolved very much in a linear fashion where we've taken stuff, made stuff, use it without thinking what happens to it at end of life. Now in between about 2012, 2015, we worked on it was actually a PhD research project that was partly run in conjunction with what was HP, it's now HPE. And we were looking at the embodied impacts of a whole data center, the infrastructure, the building, and the IT equipment. And based on energy mix at the time, and it has changed, there was a lot more coal, etc. in 2015 when we published papers. The ratio would be slightly different now because the renewable content of our grid mix has increased significantly. But you know that the operational energy impact at the time was equivalent over life of a data center of 60 years to about 75%. The remaining impact was attributed to the building itself or the facilities, and 85% of that percentage was attributable to IT equipment, which means that, okay, we say, yeah, great, let's look at operational energy, etc., and the impact of that, but we can't afford to continue to do that. We've got to look at everything else, particularly when you look at figures like this. So we need to move from the linear to the circular economy, which is an enormous challenge. It's not just technical, etc. It's a sort of psychological and behavioral challenge as well. And there's a myth. My first myth is that the circular economy is just about recycling, and it isn't. It's about a lot more. It's about making products that are a lot more materials efficient, resource efficient. It's about extending the life of products, which is incredibly important. I'll come back to that in a moment or two. And then recycling, and when you can't recycle stuff, you incinerate it and recover energy, and you absolutely minimize the amount of stuff that ends up in the ground being wasted, which at the moment we are not doing. We are disposing of far too much stuff, which not only wastes resources but wastes money as well. So myth number 2, e-waste is recycled. Well, no, it isn't. At the moment, globally, only 20% is formally collected. It's better in the EU, it's about 48%. But of the stuff that is collected, I mean, there's an awful lot of stuff that is processed sort of under the wire, it's either sold on or whatever. But of the stuff that is collected, a minimum percentage of materials types not by mass, but materials types, a minimum percentage is actually recycled. And the stuff that's recycled is the stuff that's easy to do, like anything with iron in it. So steel, think about server casings, for example. Aluminium, copper, and because of the inherent value of gold, which is in a lot of IT equipment, that is recycled as well. And again, we need to have a major shift here because in 2014, the EU recognized 10 to 14 materials as being critical. Now that number has increased to 30, and the materials are critical because of the amount that is as yet unmined and left in the ground, the geopolitical location of many of the materials, and also the amount of, or the level of recycling at the moment. So we've got a big, big challenge because the data center industry, IT, etc., electronic sectors, they all are absolutely dependent on critical raw materials to function. And if we look at this map here, you can see the geographical location of many of these materials that are so important to the sector is China. And that's, you know, it's just coincidental that they happen to have more neodymium or whatever than anyone else in the world, although the only resources are based there. Many of the materials that are important to us come from geopolitically unstable regions, like tantalum mainly comes from Central Africa, and the horror stories about the mining industry there have to be seen to be believed. It's shocking. So circularity or recycling, etc., will help us to be able to reuse materials, to maintain control over materials and so forth. But that is a daunting prospect. And I've heard people say, ooh, circular economy for the data center industry is impossible. Well, I would dispute that. It's about changing ideas and behaviors, etc., and the will to do it. So based on experience of working with the industry, I was very conscious that we needed to do something, and from talking to like-minded people, they also agreed. So I set up the CEDaCI project, which is interdisciplinary. We got funding in the end of 2018, and we've been running since. We brought together stakeholders, people who don't normally talk to each other have been talking to each other, which is essential to accelerate the circular economy in any industry. You need to learn from everybody who works in the sector. And the project uses whole life thinking, which is, again, important. And there are two key things within the project and actually within the data center industry itself. One thing is we are reacting to the challenges that we face at the moment. There are millions of tons of equipment in circulation or that have been stockpiled or whatever. And so with the reaction is, what do we do with that? We want to extend life, which we have to do because we haven't got a good recycling infrastructure. And the second thing is recycling and developing new technologies to increase reclamation and reuse of critical materials. And then the proactive bit is looking forwards rather than just saying, well, we're going to do the same again. It's designing equipment that is fit for circularity. So one of the unique things in our project, we use primary source data, we roll our sleeves up, we disassemble stuff, we don't use assumptions, and we make inventories. The majority of the data is based, particularly materials content, is based on work that's done by our French partners where they have analysed the content of PCBs, etc., through their really extensive lab-based work. And so that's really important as well, because an awful lot of the stuff that you see floating around, it's based on extrapolated data or on assumptions. So our data is not. It's mainly primary. Another myth, which is that carbon assessment is accurate. We've been sort of drawn down this road of looking at carbon because of the emphasis on operational energy and operational energy efficiency. Once you start looking at materials, you realize that carbon is only a tiny part of the picture, and many, many other factors contribute to the impact of materials. Think about mining. one of the most toxic mining processes is gold. The tailings, which are the bits that are left over after you've got the nice stuff out of the, the ground, are really toxic. And there's a lot of mercury and sulfides and all sorts of gunk that, damages water sources, people who live in the area, etc. That's all left behind. If you're just looking at carbon assessment, anything like remotely connected with any other materials is just completely ignored. It's excluded from the assessment, and therefore are they accurate? Not really. So what we've done, we looked initially at an older and a newer server, and this is sort of, one from about 2014, one from 2018, and we did carbon assessments. And if you look at the ratio of operational energy to operational impact, which is mainly energy, to embodied impact, you'll see in an older server, the operational impact accounts for about 85% of impact over life. In a slightly newer server, the ratio shifts a little to 80-20, but I question whether carbon is a good enough metric if we're thinking about circularity. Because when we look at full life cycle assessments, which include thousands of different inputs and outputs, we find the ratio shifts dramatically. And an older server, we're still looking at sort of 75% of impact, operational impact to embodied. But in new servers, which are more energy efficient, all of a sudden we find over life, the impact of operational to embodied shifts to 50-50. That you completely miss if you're just looking at carbon. And I think this is one of the problems that we have, particularly with the anything that uses electronics, because of the way that, the materials that are used, the way they're processed, etc. That's really, we're not considering that, and we really need to shift, and this justifies 101% the move to a circular economy. So we developed a compass, the Circular Data Center Compass, that's a free online resource, and it's a circularity indicator to inform decision-making for anybody involved in the sector. And of course, we use comprehensive life cycle assessment. It's very friendly to use. It's a free online resource, and I will give you the link at the end. You need to sign up and join our network, so anybody can have access to this. And basically, it allows anybody who's in procurement or has an interest in the data center and sustainability in any form whatsoever, you can do things like compare a server, a current server. You can swap components in and out to see the benefits of doing that. You can look at end-of-life impact, and you can also look at design. So comparing, again, another myth, old servers or second life servers aren't as good as new. Well, I'm going to compliment my colleagues in TechBuyer, who are key partners in our project. We've used data from the Interact project to complement our life cycle of sustainability about hardware. We've used their energy data, and you can really see, combining, again, getting the biggest picture possible, you can really see how second life servers, maybe they're not really ancient ones, but 2-3 years old, you can swap components and they function as well as brand new servers, and their impact is very often lower than brand new servers. So that's a key point. And all the data all the options in the tool, it's just drop-down menus with presets, etc. But you can get some nice snapshot or more detailed granular data of results. End of life, we've got options here. You can either calculate or, are you going to choose a business as usual conventional recycling process, or our partners T&D are developing one that reclaims critical raw materials. That's much more advantageous. Are you going to consider reuse? So not end of life, but end of first life. And we also included landfilling as a benchmark that really highlights the benefits of recycling and reuse. So that's in the tool. The third bit of the tool is the Eco-Design Evaluator. This is our proactive bit, looking forwards. And This is incredibly important because about 80% of a product's environmental impact is determined at the design phase. So this aspect of the tool, you again just choose options that align with the EU and UK circular economy package and action plan, etc., and other criteria as well. And you get live feedback as you're changing criteria. You can see how your decisions in terms of design increase or decrease circularity. And then you get nice, there's a little bar at the bottom that tells you, 85% is really good in terms of circularity at the moment. We would like to be able to design 100% circular servers. Final myth, a circular server is not possible. Well, yes, it is in terms of technology and manufacturing processes, etc. And we've focused on enterprise servers. And this is the beautiful CEDaCI server. It's simple, it's standardized, it has a modular platform, it's easy to disassemble, which is absolutely essential for reuse of parts, harvesting parts, upgrades, etc., and also for recycling. But also, a key thing in circularity is resource efficiency. So we've reduced overall mass by 33% without compromising performance. We've rationalized the number of components by about 50%. In servers at the moment, there are loads of things that are just in there that aren't really of much use at all. So we can strip those out. And we've also reduced the mass of plastics, which might sound a bit contradictory, because if you think, you want a lightweight piece of equipment, or lightest weight possible piece of equipment to minimize the impact of transport. But actually, circularity is not just about designing this generation of products. It's about thinking, what are we going to do in the future? How can we design products that are fit for generations to come? So we've replaced, where possible, and it's not absolutely possible, but we've replaced, where possible, plastic components with metal components because they can be easily recycled. Plastics are very problematic when you want to recycle them. So call to action. We would love you to join our training sessions and to use the compass. It's there. We want to populate the databases more, so we're really, really keen to take in more equipment and process, build inventories and carry out more life cycle assessments. But the big thing, and it's a bit of a sort of da-da moment, I guess, we recently found out that we are now members of the OPC organization, which is brilliant. And this also means, which is really important legacy from our project, that we're going to be able to publish our drawings for the circular server via the OCP platform, and we're going to share them. And I wouldn't have been able to stand up here and talk to you today if I hadn't been working with a fantastic pan-European team. So thanks to everybody who's been involved in the project, and that's it. Thank you very much. Has anybody got questions? Or oh, thanks, John. What a surprise.
What is do you know the ratio? I mean, obviously, between the electronic waste from data centers and from commodity and household electronics, because my feeling is it's much bigger in the consumables in the commodity space.
Yeah, it is. It's unfortunately, because we've got an idea of how much stuff is sold every year, obviously, but collection, because there aren't any formal statistics available. We just know that 20% is formally collected globally, 48% in Europe. So we haven't actually got any, definitive stats. But I think in the sector, and this is a key thing, of course, business is, we're legislated, so you have to recycle stuff, send it off. Once you give it to somebody, it becomes their responsibility with what they do with it. And unfortunately, there are a lot of people who are doing illegal things with electronics equipment, you know, they claim to be legitimate recyclers and they're not. So that makes the, you know, the calculations even more complex. The consumer electronics sector, there is no legislation. We are advised, asked, etc., to take, you know, hairdryers, toasters, whatever it may be, to your local recycling plant. Whether people do or not, it's personal choice, and an awful lot of stuff actually ends up in the domestic waste stream. So it's difficult to, you know, have definite numbers, but consumer electronics is certainly a hell of a lot bigger than e-waste from the data center industry for a variety of reasons. Yeah.
Yeah, I came across an interesting piece of work by some guys at the University of Louvain, and they were looking at using the main boards from smartphones to produce Wi-Fi access points with a little bit more extra electronics, so they get a second life. But the problem with that is that you need the electronics to be in a form that it allows it to be upgraded in that fashion.
Yeah.
And I think, you know, the design process, you know, needs to be brought into the whole environment to try and to allow this to happen.
Yeah.
I mean, do you know what's happening in that space in terms of?
Yeah, okay, we've designed a circular server in inverted commas because the bits that we've made circular are the bits that are very easy to make circular. The guts, the PCB, is the big, big challenge for numerous reasons because, and it goes down to sort of atomic level, the way in which materials function to either compute or whatever is determined, you know, at atomic level. So making individual components, redesigning them is a huge, huge challenge. I think in terms of configuration of boards, there is a lot more potential in that. But I don't know if we can solve that, then that's the holy grail of circularity. Yeah.
Okay. Yeah. Well, I think nobody should own anything. It should be leased all the time. And then the you know, if data centers don't own it, if we don't own it, then the responsibility is with the source.
I think
And
a good model is Apple. You know, they actually have in their business, you know, kind of model now that they're taking back at least 25% of all devices back from consumers. And they're trying to look for ways to increase that, and they claim to have, you know, 80% recycling of everything that they can. So they're setting.
Yeah, I think that there may be a little bit of creativity in the numbers there, but
marketing.
yeah, I mean, I think, you know, that I think there's an awful lot of intention, and it's this. We can solve some of the technical problems, but we really need to change behaviours as well, and also to develop much better infrastructures. And you're right, John, one of the behavioural changes we need to make, and it could actually be realised in business perhaps more than in consumer areas, is leasing. You know, so server manufacturers, in order to maintain control, etc., of the products, could develop leasing models. Some are beginning to do that. Well, I heard that HP were keen on doing that. But again, you know, it's difficult to know how much information in the information sphere is greenwashing and how much is actually happening. It's difficult to find out. Anyway, thank you very much.